Okay, here's a puzzle for you. You're building a website and you have a form on that site and you want to do one of the most basic things in the world. You want to validate the form on the client using JavaScript. For this simple example, we'll say that you want the field to turn pink if it's empty and go to another page if it's not. Simple. So here's the puzzle. How do you test drive this code? I'm James Shore, and this is my lessons learned about DOM events, UI testing, and Selenium. I'm recording this on April 4th, 2013. In today's episode, we'll start with a review of DOM events, then we'll consider UI testing strategies. Finally, we'll combine the two subjects by using each strategy to test a simple web page. First, let's look at DOM events. Here's the example page I was talking about. It's pretty simple. We've got a text field and a submit link. And what we want to have happen here is when the submit button is clicked, we're going to look at the field and see if it's empty or not. If it's empty, we'll turn it pink. And if it's not, we'll follow the submit link. And the way you do this is with DOM events. Now you'll recall that the DOM is the internal in-memory structure of your web page. So everything on your page has an element, a DOM element associated with that. And those are arranged in a tree structure that would look more or less like this. What you can do is you can associate event handlers with any of these elements. And what we're going to do is we're going to associate an event handler with that submit link. But we can actually put event handlers on any of these elements that we want. The way we put an event handler on the submit link is by calling add event listener, specifying exactly which event we want to listen for, and then providing a function to run when that event occurs. So you call add event listener, and that will attach the event handler to that element. Now that it's attached, how does it actually work? Well, let's look at that. When an event is triggered, all the events handlers execute, but it's not as simple as just running the event handler on the element that was clicked. There's actually three phases that go through. There's a capturing phase, a target phase, and a bubbling phase. And then the browser's default action occurs, in this case to follow the link. Let's look at this in more detail. We'll say that the user clicks the submit button there. The browser will then create the click event, and it will start out way up here at the window in the capturing phase. And it will run all the event handlers that are attached to the window that have been defined to run during the capture phase. Then the event will proceed down to the document and run all the event handlers on the document that were set up to run during the capture phase. And then the HTML elements event handlers and the body elements event handlers, the P tag event handlers, and then finally it gets down to the actual A tag, the hyperlink that was clicked. At that point, we're no longer in the capture phase. Now we're in the target phase because this is the actual target element that was clicked. In the target phase, all the event handlers on the target are processed, which includes our event handler. So our event handler runs. And then we go into the bubble phase. Same thing in reverse. Now we go back up through the DOM and run all the event handlers on every element. So we run all the event handlers for the P element, and then the body element, and then the HTML element, the document, and then finally the window. That's not all. All the event handlers have been run, but now we go into one last pseudo phase, which is the default action. The web browser follows the link. It does whatever it wants to do for the link. And this can vary by browser, but it tends to be fairly similar on most browsers, except maybe IE, of course. So to summarize, when an event is triggered, the event handlers execute. They go through a capturing phase, a target phase, and a bubbling phase, and then the default action occurs. Now you do have some control over this process. Particularly what you can do is you can cancel various pieces of it. So you can cancel the event handling by calling event.stopPropagation or event.stopImmediatePropagation. And the difference between these is whether or not it waits until it's done with all the event handlers on the current element or not. Stop propagation will run the remaining event handlers for the element that is currently being processed and then stop. Stop immediate propagation will run your current event handler and then run nothing else. Let's look at how this works. Let's say that the user clicks the submit button, the event is created, it goes on down, and then in our event handler in the target phase, we run event.stopPropagation. Any additional event handlers on that target element would run, but nothing else would run after that. Stop propagation means no more event handling after the current element. Instead, what we do is we'd go into the default action and the web browser would follow the link. It's important to notice here that stop propagation does not prevent the web browser's default from happening. So stop propagation won't prevent the link from being followed. All that will do is will prevent other event handlers from running, which can be useful, but isn't necessarily what you always want. So if you want to prevent that default action from occurring, you need to run event.prevent default. Let's see how this works. It's very similar. User clicks the submit button, the event comes down through in the capture phase, we get to our target and run our event handler, and in our event handler we call event.prevent default. This is going to tell the browser, don't do your default action. However, it won't stop the events from being handled by other event handlers. So we will continue on to our bubble phase and we'll go back up through the DOM all the way to the window. But now, once we reach the window, rather than going into the default action phase, it will just stop. The link won't be followed. And this is useful for us because remember, what we want to do is when the submit link is pressed, we want to look at that field and decide whether or not the user follows through to the next web page, or if we stop them and turn that field pink. So that is a brief summary of DOM events. You can attach an event handler to a DOM element by saying add event listener. And when an event is triggered, all the event handlers will execute starting at the top of the DOM all the way down to the target element in the capturing phase. Then all the event handlers for the target in the target phase, and then all the way back up through the DOM tree in the bubbling phase. You can cancel this process with stop propagation, but then the default action will occur following a link or clicking a checkbox or something else, and you can cancel that with event.prevent default. Now let's look at the strategies for doing these tests. That's how you actually write the code to handle events, but how do you test it? Well, there are three different approaches. You can use a robot, you can simulate the events, or you can create a thin UI layer and bypass the events entirely. Let's look at them in turn. The first strategy is to use a robot to control the UI, just as if a real person was controlling the UI. In order to understand this, we need to take a quick look at how the browser works. What happens is when the user clicks something on the screen, the OS tells the browser, you've had a click on your window in this location. So the OS, the operating system, tells the browser, here's a click. The browser takes that and turns it into a click event, which then goes through the DOM tree as we discussed earlier. So when you're using a robot, what you're doing is you've actually got a separate process, a robot process, that you tell to create a click. So you tell the robot, create a click for me. And the robot turns that into an OS level click. It actually says to the OS, simulate a click in the window at this location. And the OS will send that click to the browser, which turns it back into a click event and has it go through the DOM as normal. So you can see here that using a robot is as close to having a real person at the keyboard and mouse as you can possibly get. And that's the real advantage of this strategy, is it's very real, and it can double as a smoke test if you need to. The disadvantage is that it is very complex. It's slow and it's brittle. It can be an order of magnitude or 2 or even 3 orders of magnitude slower than working directly in process using one of the other strategies. It also often requires alternate tooling and configuration. Cross-browser automation can be difficult. Isolating your units for unit testing can be very difficult because you're actually talking across processes. Overall, this is my least favorite strategy, but it is a fairly easy to understand one. You're actually acting like a user clicking the mouse. And it is a legitimate strategy. It does have its uses. A second strategy is to simulate the user's events. This is pretty straightforward, especially in JavaScript. What you do is you create the event that you want and you just dispatch it into the browser's event handling system. Because JavaScript is pretty flexible in this way, you can actually just have your tests send the event to the UI code all in one process, and that's all there is to it. That is a fantastic aspect of this strategy. It's my favorite strategy because it's really pretty simple. It's real enough in that it is actually exercising the event subsystem and your event handlers, but it's not going through all the complexity that the robots do. The downside is that you're not actually clicking the mouse. Now, when the user clicks the mouse on the screen, a lot of different events come through. There's a mouse down event, there might be a little mouse move event, there's a mouse up event, and then the click event happens. Using this strategy, you tend not to actually have all those real events. You just put in the events you care about. And as a result, this is not actually the same as a user clicking. And there's a chance, perhaps small, that your events won't accurately simulate the real world. So it does require manual verification. But once it's been verified, you can tend to trust it. A third strategy is to create a thin, untested UI layer. You may have heard this as using a presentation layer. The way this works is you avoid the event system entirely. Instead, you extract out all your presentation logic from your UI code. You keep your UI code as thin as possible, and you test the presentation logic rather than the UI code. One way to do this would be to create a fake event, send that into your presentation logic, and see what happens. Now you'll notice that in this approach, you're not testing the UI at all, and that's a disadvantage because it's not at all real. However, it's very, very fast, and your tests tend to be fairly simple. But your setup can be complex because you've got to create this fake event. I like this strategy because it's fast. It's a lot faster than the robot approach, but I don't like it because it's not real. It is my second choice after doing the simulation approach because it isn't real. Another disadvantage of it is that it really forces your design to go in a particular direction. That design direction can be good. It's forcing you to separate your presentation logic from your UI, which can be good. It can cause unnecessary design complexity. Also, you have to be careful that your thin UI doesn't grow because that is untested code. There's a lot of temptation to put stuff in there just because it's easier, but it's untested, so you have to be really rigorous about moving all of your code out of the UI and into your presentation layer. To summarize, 3 strategies here. You can use a robot, you can simulate the events, or you can create a thin UI layer. My favorite approach is to simulate the events. It's real enough, it's fast enough. It does require manual verification because you're not doing all the events that a real user would do. But once it's set up, it tends to work really well. If I can't do that, or if I'm really interested in speed, I'll create the thin UI layer. It's very fast, but it does tend to cause unnecessary design complexity. And then if I need to be sure that I'm doing what the real user does, I'll use a robot. Now, let's look at how they actually work out in practice. Let's start out by just looking at the actual production code. It's very simple and straightforward. As I said before, you click the link, and if the example field is empty, it turns it pink. If it's got stuff in it, it submits the link and goes to the Let's Code JavaScript homepage. The actual code to do this is fairly straightforward as well. We add an event listener to the click event on the submit link, and then when that is called, we run handle submit. Now this could be inline except that it needs to be called by thin UI test, and that's actually an example of what I was talking about. This code is not very complex, and it would be perfectly fine for it all to be within just one function, but that would not work with the thin UI test strategy, so I had to pull it out. Now, when we handle the submit event, we look at the value, and if there's any value in it, we simply return. What that does is that allows the browser to do its default, which is to follow the link. However, there is no value. Then we tell the browser to prevent the default, thus preventing the link from being followed. And then we set the required field class on the text field. And we have CSS set up in our actual HTML that will cause that to turn pink. Now there are 3 strategies here. There's the robot test is test strategy number 1 of using the robot to interact with the UI. The simulate test is test strategy number 2. And the thin UI test is test strategy number 3. Before we look at the details of those, I want to show you something. I'm going to run all these tests. I want you to notice how much slower the robot tests are relative to the other code. So the other 2 tests, the simulate test and the thin UI test, those run using Testacular, and they take literally a fraction of a second. The longest one takes 0.3 of a second. But the robot test, which uses Selenium, that takes 5 seconds. That is literally an order of magnitude slower than the Testacular tests. And that is the reason I don't care for the robot tests, because they are so much slower. I've only got 3 tests running here, but as you build more tests and more tests, then that really builds up. I'm going to run it again. Watch how long this takes. So their testacular is all done. Now it's spinning up the Selenium browser, doing the robot stuff. It's so slow you can literally see the test running. Again, it's not a problem right now when we've only got a few tests. It's actually noticeable though. If you're doing test-driven development and running your tests every 30 seconds or every minute, you'd notice this. It feels a little bit painful when your tests get up around 5 to 10 seconds. Okay, let's look at how these strategies work out in practice. First one is to use a robot to interact with the UI. What we're doing here is running Selenium. Selenium is a popular tool for automating web browsers. It's well done. I have to say though, the robot approach is complicated. It took me hours and hours and hours to get this working. Here's how it works. We launch the Selenium browser. We launch the web server because this has to operate against a web server. And then run all of our tests. And after it's done, we quit the Selenium server and we quit the web server. So you see some of the complexity of using robots right here. And then before each test, we tell Selenium to actually load the page that we care about, find the elements on the page, and then tell the setup that we are done. Again, some complexity here as a result of Selenium being asynchronous. It's using promises, which I'm not going to explain right now, but you can see some complexity there. We have 3 things we're testing in each of these tests. We check to see that the code follows the link when the field is not empty. We check to see that it doesn't follow the link when the field is empty, and we set a CSS class when the field is empty. The way we do that with Selenium is we actually literally type on the keyboard. We type in not empty into the text field, and we click the link. And then we look to see what the title of the page is. If the title is changed, if it's no longer the example page title, then we can assume that the link was followed. Similarly, here we click the link without putting any text in, so it's empty. Then we look at the title, and if it has not changed, if it's still the example page, we know we're on the right page. And finally, we set the CS class. We look at the class attribute on the text field. So this code is a bit complicated, but not too bad, fairly straightforward. The complexity of using the robot really comes from all the other stuff you have to have around it. And you can't really see it from this example, but building this, it was really fragile and it took a lot of work, a lot more work than writing the other tests. And of course, you see how slow it is. So that's an example of the robot approach. You're welcome to look at this code. It's available at this link here. Let's go ahead and look at the other 2 examples. Simulate test. This is my favorite approach. What we're doing here is we're simulating the user's actions. Like other DOM testing, we need to set up this is running in Testacular, so we start out by setting up our DOM. We're going to put in our text field and submit link, and then we're going to get the element out. And then we'll actually run the production code here. Then when we're done, we'll take those out. To check our 3 tests, follows the link, does not follow the link, and sets the CSS class, we are going to add an event listener of our own to the click event on the submit link, and then find out if the default was prevented. The DOM has a property that tells us if the default has already been prevented, and so we're going to look at that. Then we set the text field value to not empty, we click the submit link, and then we expect that the event has been canceled, the default's been prevented. Similar deal with not following the link when the field is empty, just same thing in reverse. And finally, when the field is empty, we're going to look at the attribute. You can see that the actual code is fairly similar to the robot approach. The stuff that we have to do here for setting up our own event listener to look at the default prevented value is a bit tricky. And clicking the submit link is also tricky. We have to create the event here, initialize it with a whole bunch of obscure stuff, and then dispatch the event. So when you're doing this kind of testing for real, you tend to want to abstract this out, as we've done over in the live channel. Overall, I'm pretty happy with this code. I think that this is a bit more complex than it needs to be, and I think this is a bit more complex than I would like it to be. But overall, it's nice and fast, and it is fairly real, which is why I like this simulation code. Let's look at our third strategy. This is keeping the UI thin without testing it. Now, in this strategy, we're not actually calling our production code. We're calling handle submit, which is called when the click event handler fires. So you'll see here that in our thin UI test, we're not actually creating the event. Instead, we're skipping that logic entirely and just jumping down here to what happens when the event is fired. And this is what I mean when I say there's a thin UI layer and moving our event handling code out into something that we can test. So this code is not tested at all by this thin UI test. Now to make this work, we have to pass in a fake text field and a fake event. And this is something I really dislike about this strategy. You spend a lot of effort setting up these fakes. We have to tell it that there's the set attribute function and the prevent default function, because those are what are called inside of our real code. And if they didn't exist, the test would fail. Other than that, though, the test is fairly easy to read. It's actually the easiest to read of all three. We set the value, we call our handle submit, and then we expect the value to be false. Here, we expect it to be true here, and we look at our parameters here. So fairly straightforward. So those are our three strategies. We've got the robot approach, the simulation approach, and the thin UI approach. To look at these in more detail, check out the code, which is available at the link on your screen. In summary, we're looking at how to test UIs. We've looked at how DOM events work. You can handle events by calling add event listener, and then when an event is triggered, the event handlers execute in three phases: a capturing phase, a target phase, and a bubbling phase, and then the browser executes a default action. You can cancel the event handlers by calling event.stoppropagation, and you can cancel the browser default by calling event.preventDefault. We've also looked at three strategies for UI testing: using a robot, simulating the events, and creating a thin UI layer. My favorite is to simulate the events, but I'll also use the other two when appropriate. You can find examples of each of those three strategies at the link on your screen. Thanks very much for watching, and I'll see you next time.